मैं डॉक्टर अंजू अग्रवाल, एसोसिएट प्रोफेसर केमिस्ट्री। आज हम एम.Sc केमिस्ट्री सेमेस्टर 3 के फिजिकल केमिस्ट्री के पेपर न्यूक्लियर के इलेक्टिव पेपर न्यूक्लियर केमिस्ट्री में सेकेंड यूनिट में हम जनरल कैरेक्टरिस्टिक्स ऑफ रेडियोएक्टिव डिके के बारे में पढ़ेंगे। तो यहाँ पर इससे पहले हमने डिफरेंट टाइप्स ऑफ मोड्स ऑफ रेडियोएक्टिव डिके के बारे में पढ़ा था। तो आज हम जनरल कैरेक्टरिस्टिक्स ऑफ रेडियोएक्टिव डिके के बारे में पढ़ेंगे। सम फीचर्स कॉमन टू ऑल फॉर्म्स ऑफ रेडियोएक्टिव डिके आर लिस्टेड बिलो। इसमें पहला है मास लॉस एंड एनर्जी रिलीज। The sum of masses of products of nuclear decay is always less than the mass of parent atom. That is, a radioactive decay is always accompanied by a net loss of mass, and it is this which makes the process spontaneous and irreversible. The equivalent of the mass loss appears as the recoil energy of the daughter atom and the kinetic energy of the particles and the energy of the photons emitted, if any, during the process. For example, phosphorus gives sulfur plus beta particle plus neutrino. यहाँ पर मास पर यूनिट जो है 31.973 है। 31.973908 is greater than 31.972074. Delta M equal to minus 0.001834 units. Total energy released equals to delta M multiplied by 931 mega electron volt equals to 1.705 mega electron volt. This energy is shared between the recoil atom, 32 sulfur and beta particle and nu bar. Because of the continuous decay of atoms and energy release, all radioactive samples tends to keep warmer relative to surroundings. Second है nuclear radiations. During the decay of radioactive nucleus, either helium ions, that is alpha decay, or electrons, that is beta decay, or positron, that is beta plus decay, are emitted. These particles are in many cases accompanied by pure electromagnetic radiation in the form of gamma photons. Further, the beta plus minus particles are accompanied invariably by neutrinos, nu bar with beta particles, beta minus, and nu with beta plus. These radiations are of higher energy, 10 to the power 3 to 10 to the power 6 electron volt, and have high penetrating power through the matter. The ranges of penetration through air by alpha beta particles and gamma photons of a given energy are in the order gamma greater than R beta greater than R alpha. They ionize the atoms of the matter. They pass through and thereby lose their energy gradually. The ionizing power being in the reverse order. I alpha is greater than I beta greater than I gamma. If the air through which the radiation passes be supersaturated with water vapor, the ions formed act as nuclei for the condensation of water. The droplets being visible can be photographed under proper conditions, and the track of the water drops is also the track of the alpha or beta radiation. A cloud chamber for photographing the track of alpha or beta or other charged particles was first devised by C.T.R. Wilson in 1896. The alpha tracks are short and straight, nearly of equal length and end abruptly. The beta tracks, on the other hand, are thinner, much longer, very irregular and zigzag, as shown in figure 4.2, while the gamma radiation, because of its feeble ionizing power, leaves hardly any track. The nuclear radiations, because of their higher energy 10 to the power 3 to 10 to the power 6 electron volts, affect characteristics, physical and chemical reactions in the matter they pass through, referred to as radiation damage, which forms the subject of radiation chemistry. The blackening of the photographic plate observed by Becquerel is an instance. The possibility of using nuclear radiations for industrial purposes is discussed in other section. The energy spectra of these radiations are characteristics. The alpha and gamma spectra consist of a few sharp monoenergic lines, while the beta spectrum is a continuous from nearly zero to a definite maxima. For instance, the alpha from 96 to 244 cm consists of 4 lines 5.508, 5.568, 5.763 and 5.805 mega electron volt, and the gammas are 0.292, 0.142 and 0.043 mega electron volt, while the beta spectrum from 2 bismuth 210 is a continuous from 0 to an upper limit of 1.17 mega electron volt, with a broad peak around 0.1 to 0.3 mega electron volt. आज के लिए बस इतना ही. थैंक्स.